we're not going to spend too much time looking at where this formula comes from, but we will spend some time before you get going. Once you understand this, the actual plugging the numbers in and everything is just dead easy to do. It's the understanding why for this that's more important. We have two cases, right? We have one case where it does have a finite sum. And what was that case? The case where it does have a finite sum was where r was, the absolute value of r is less than 1. In other words, the number part is less than 1. And we have the other case where it does not, right? Okay, it does not have a finite sum. In other words, where absolute value of r is greater than 1. So here's our two cases we'll look at. Remember that to find the sum of a geometric series, it was a times 1. What was the formula again? Have you memorized it yet? 1 minus r to the n. A times 1 minus r to the n over 1 minus r. If the ratio is less than 1. This all involves you thinking about what happens with this and what happens with this as, what happens here as I'm going to do this, as n approaches infinity. This is a calculus type of terminology. This arrow means here n approaches infinity. In everyday language, that means as n gets bigger and bigger without stopping. As n approaches infinity means as n gets larger and larger without stopping. That's what that means. This n with an arrow and infinity means as n is getting bigger and bigger and bigger without stopping, as n approaches infinity. What happens to this expression? Just that part that's highlighted in yellow there. If you take a number smaller than 1, and I'm pretty sure you know this already, if you take a number smaller than 1 and raise it to a bigger and bigger power, think about what's going to happen. We can go to the calculator here if you want. That is not the calculator. Give me a number that's where its absolute value is less than 1. 0.25. Very good. Okay. Now we're going to raise that number to a higher and higher power. Raising that to a higher and higher power is just multiplying by itself, right? So I'm going to take that number now and multiply it by itself repeatedly, right? So there's to the power of 2. This is to the power of 3. To the power of 4. I'm repeatedly multiplying it. What happens to a number when you multiply it by itself? Raise it to a higher and higher power if it's smaller than 1. It's getting smaller and smaller, right? This is smaller and smaller here, right? This is basically pretty insignificant. If you kept going with this, depending on how fast you push the button, the calculator is going to eventually not be able to comprehend it anymore. I know you're excited to get to the end here. We don't want to stop now, right? What's going to happen eventually? You're going to exceed the computational capacity of this calculator. It can only go to about 100 decimal places, which is, it's getting close now, right? This is making for some exciting video. Okay? I know you're excited. I wished you had picked something smaller than 0.25 now. Would have happened a little faster. Maybe we should stop right now. I'll keep going, okay. Now, what has it done? It's not actually 0, is it? It's rounded it off because that's the limit of what it can do. If it had higher powers, if you use a computer or something like that, it's not higher powers. If it had more power than this, it would keep going here, right? If you used a computer, it could keep going. What is this basically turning into? It said, I give up. This is good enough for you right now, right? Basically, it's this. It's not actually that, but it's pretty close to that. If we let this, I don't want to get too far into calculus with this, but If we let this go, if n gets really large here, what is this expression equal to for all intents and purposes? What did you say? No, go back here. What was it basically close to here? This is not a negative number. This is like 0.000000, like 98 zeros and then a 1. This is basically 0, right? If you let n get bigger and bigger and bigger, this is equal to 0. It's not equal to 0, but it's pretty close to 0. If you're going to take calculus at some point, you would say this. I'm going to write it down here. You would say that the limit of that expression, it means what happens to this as n approaches infinity. The limit of this expression as n approaches infinity, it just means what happens to this, what's the behavior as n gets bigger and bigger and bigger. As n gets bigger and bigger and bigger, this pretty much turns into a 0, so we can imagine it being a 0. And then what is that whole thing equal to? 1 minus 0 here is basically 1, right? I should move this. This doesn't belong down here. What is this basically equal to here? A over 1 minus r. Where have you seen that? It's on that page, right? That's the formula. The only difference between what I wrote here, I wrote S infinity is A over 1 minus R. Up here it's written S equals A over 1 minus R. I think it should say S infinity. The only reason I wrote S is because on your provincial exam formula sheet, the formula sheet I'm going to give you, it just says S. I'm thinking that they just didn't want to give away that's... You have to know what that is, I guess, but really it should say S infinity is A over 1 minus R. You can test it for what we did, the pizza example up above. Go back up here and plug the numbers in. I don't have tons of space here, but maybe I have some over at the side here. If we do S infinity for this first example, A over 1 minus R, the first term was 1/2. On the bottom here you have 1 minus 1/2. A half divided by a half is what? Is 1. That's what we said the sum was. It's 1. We said that the sum for this one, where was it here? This one was somewhere in the neighborhood of, remember we went down here, then back here, then over here. It ended up being about there. It's roughly in the neighborhood somewhere between 1/4 and 1/2. It's somewhere in between there. If you use this formula, you can figure out exactly what it is. Because if you say that the first term's 1/2 and the ratio is -1/2, you get here 1/2 divided by, what's 1 minus -1/2? It's actually like 1 plus 1/2. So it's actually like 1/2 divided by 1 1/2, 3/2. This is actually 1/3 if you work it out. Okay? The sum of that is 1/3. If you start by eating a pizza, throwing up 1/4, eating an 1/8, throwing up a 1/16, the end result is you have 1/3 of a pizza in your stomach if it goes on infinitely. Okay? That's the sum. Does that apply in the other case?